example, that mathematics isn't really a proof of anything at all, huh? Since it's very often taken as, because the math works, then, you know, it must be reality and it must be a true description of reality. But as we'll see, that's not the case. So mathematics, being a formal science, is based on definitions and axioms. A mathematician cannot prove the truth of his axioms, nor can he prove anything unless he takes them for granted. So it doesn't matter what he starts with. He has to believe in his axioms to believe in his conclusions. But definitions are neither true nor false per se, because it's simply a man-made definition by somebody. So there's no way of necessarily saying that this is true or false unless there is an agreement that these are, in fact, common notions or universal ideas or self-evident truths, right? Which is the thing that's never talked about. So,
self-evident.
Sorry?
Self-evident truths.
Yeah.
Yeah.
So our contention is that mathematics cannot be a proof of anything. I don't really think any mathematician would deny that. Huh? If they want to, they can try. But let's just explain it more closely to everybody. Then I think the first thing that we should look at is this distinction between proper quantities and improper quantities. The idea comes from Aristotle, so it's whatever, thousands of years old, and was, as far as I'm concerned, last brought up by Thomas Reid.
The what?
Sorry?
You said the idea.
Oh, yeah.
The idea was brought up by Aristotle.
Oh, the concept, the notion, I don't know what fucking word to use anymore.
They've got us bamboozled with their words.
Yeah, so the main thing... Oh, sorry.
I was just going to say, I think that's what the Tower of Babel was all about. I actually wrote it in my Word document about the stuff I'm working on at the moment. I wrote that perhaps the Tower of Babel story is just a cover for what really happened.
Yeah, I think so too. This whole talk about, you know, was it God that threw in those languages to confuse us all?
Yeah,
or the Babylonian connection. I think it's something to do with these natural language that we don't see anymore and that we rely on the spoken word. But also it's used for the obfuscation of mathematical language as well, and these formal things too. So, yeah. So the first bit is just a kind of recap of what is a proper quantity. The best definition that I can find is this one. That which is measured by its own kind, and that which is composed of similar parts. And these definitions are the same because what is made up of similar parts may be measured by its own kind, and what is measured by its own kind must be made up of similar parts. And if that sounds a little bit too abstract, then here's a bigger overview of what's meant by that. So when something is measurable by its own kind, such as number, and number is measured by number. So the number 15, for example, is made up of 3 times 5, both of which are also numbers. Or any duration that we try and measure is measured by time. Now that can be things like days, hours, minutes, heartbeats, water drips, sands, clocks, you name it. But basically it's measured by its own kind. Lines are measured by length, surfaces are measured by area, solids are measured by volume. So that, if you like, all these things can be measured by themselves. If I want to measure the length of a line, then I take a small line, as in a ruler, and I try and see how many times that ruler can fit into a longer line. So a line itself is measured by a smaller line, or a length that we define. And it's measurable by itself, or by its own kind. And a line is made up of similar parts, i.e. so many rulers fit into that line, for example. Yeah.
Yep.
Same can be said of all of these things. There's a special exception to do with ratio. So the ratio of one thing to another, or what we call a proportion, is also a proper quantity, because a ratio can also be described in terms of itself. So 3/12 is the same as 1/4, for example. And basically a ratio can also be measured by its own kind. So what Aristotle and Reid basically both agree on is that number, duration, and extension, and by extension is meant any of the dimensions in space, so either linear surfaces or volumes, are the measures of themselves and of all things else that are measurable, and that these are therefore the proper and immediate objects of the mathematical sciences. Because if you can't measure something, then it shouldn't be an object of mathematical reasoning. Yeah.
Not in the working with reality.
That's right. Yep. Now, as in opposition, if you like, to proper quantities, there are things called improper quantities. And an improper quantity is defined as being that which cannot be measured by its own kind, but only by some proper quantity that is related to it. And a very obvious example of well, it's maybe not obvious because most people don't think about things this way, but a very well-known example of an improper quantity is the thing that we call speed. And speed is defined to be the distance traveled over the time taken, i.e. it's a unit of length divided by some unit of time.
Yep.
And we can basically see that speed is an improper quantity because it cannot be measured by its own kind. We cannot measure speed by speed. Generally speaking, if we see something moving, then we can say it's going faster or slower than something else because we can see it overtaking or obstructing something else in our visual field, for example.
Yep.
But we can't actually measure what it is.
Yep.
Directly.
Overtaking or overtaken.
Yep, exactly. So, and if we want to measure speed, then by measuring speed, we mean that we have a clear distinction of when something is double or half or triple or whatever, right? Quadruple. That's what it means to correctly measure. If we don't know what is double or triple or quadruple or a half or a third or a quarter or any fraction, then we can't measure it. That's what the definition of a measure means, is that we can accurately say what are those doubling fractions or halving fractions or whatever.
That's why you make such a point of proportion being so critical.
Yep. And that's where it also ties in, because if you can't make that absolute correct measurement of when something is double or half, then you're left again just with the something is more or less, which is a very unquantifiable thing, right?
Yep.
And like probability would be one of those things, but that's maybe a different topic.
Yeah, well, I remember the examples you used about my wife loves me more than I love her, and things like that, not properly quantifiable.
Yeah, very subjective, and in the case of looking for an objective reality, then we need to be able to say, okay, that's exactly double.
Yep.
But as I say, to do that, then we need to, define how we're measuring something and what is the measure of it.
Yep.
So I think it can be seen here that if we define speed to be distance over time, then to understand whether something is going double the speed or whatever, we actually need to measure the distance and the time. Yeah. And those are the two proper things that belong to what we just looked at up here.
Yep.
And so that speed being an improper quantity needs to be defined in terms of two proper quantities.
Would you say that speed is about the relationship between distance and time?
Yeah, absolutely. And there's actually the sentence here that says it, I think. This applying of measure to improper quantities, i.e. things that don't have any quantity, is a kind of fiction or artifice of the mind by means of which we are enabled more easily to express and demonstrate the properties and relations of those things that do have real quantity, in this case, distance and time.
Yep.
So we're basically just defining a concept, a word, an idea, that helps us relate those two things together.
Yep.
And just to make this clear, and so that mathematicians don't scream, it is perfectly reasonable to use such an artificial, unreal concept, such as speed, but only if it has a clear definition of measure within its very definition, and that this measure is in terms of proper quantities. Because every improper quantity, is just an idea. It's not a real proper thing. It really is just a construct of the mind. So you have to be able to define it in terms of real things in its definition. Otherwise, it would not be a correct object of mathematical reasoning if we just made stuff up, right?
Yep. Well, what about when you see something go past you really quickly? You say, Jesus, that was going fast.
Yep, relative to what?
Yeah. Relative to me standing still. Relative to something that was walking past. Yeah, somebody running past me is going faster than somebody walking past me.
Yep. But to actually ascertain how fast they are in difference between each other, you have to again measure the distance and the time taken, right?
Yep. Yeah, I was just getting a little bit confused about whether or not speed did have other aspects, but it doesn't really, does it? It is only a relationship.
Yeah, I mean, it really only tries to answer two questions, right? And the one is, as far as I'm concerned, you know, how far can we travel in a given time?
Yep.
Or
how long does it take to travel a certain distance?
Yep, exactly. Those are the two questions it tries to basically answer, or that's where we use the term or the notion speed, right?
Yep.
So there can be different measures of things, right? Depending, and this is